Okay, you're given this function on the interval from 0 to 2 pi inclusive, and asked to find points of inflection for that graph. So here's the original. That means we have to apply the second derivative test. We have to do the test for points of inflection, which requires you to find the second derivative. So here's f of x. The first derivative is the derivative of the natural log of anything is 1 over the anything times the derivative of the anything, which is the derivative of sine of x is cosine of x. And just as an aside, if you want to know whether any relative maximums or minimums, you want to know when the first derivative is equal to 0. That will only happen when the numerator equals 0. This denominator is never undefined because the sine of x is always less than or equal to 1 in absolute value. So we can never get a 0 in the denominator because of this positive 2. So x would be the angles that have a cosine of 0, and those occur at pi over 2 and 3 pi over 2. And if you test the first derivative in the interval from 0 to pi over 2, that's the first quadrant where the cosine is positive. The denominator is always positive, so it's increasing interval. And we can figure out decreasing and increasing. So there's a relative maximum at pi over 2 and a relative minimum at 3 pi over 2. But anyway, onto the second derivative, we got to apply the quotient rule to this. So here's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Now you can simplify this. Distribute the negative sine of x, and you get all these negative terms in the numerator still over the denominator squared. But if we factor out a negative 1 from all these terms in the numerator, we're going to get sine squared plus cosine squared, which is always equal to 1. And this minus sign will move to the denominator. So we've got 2 sine of x plus 1 over this. And we want to know, when does this equal 0, or when is it undefined? It's never undefined because this value will always be a positive number. So we really want to know, when does the numerator equal 0? Well, it equals 0 when the sine of x equals negative 1/2. So x is the angle, any angle that has a sine of negative 1/2 in the interval from 0 to 2 pi. That occurs at 7 pi over 6 and 11 pi over 6. You have to draw a unit circle or a circle like this with a reference triangle. This is negative 1, this is 2, this is negative radical 3. So this is 30 degrees here, or pi over 6. And pi plus pi over 6 is 7 pi over 6. Likewise, there's another angle over here in the first quadrant where this is negative 1, 2, square root of 3. This is again 30 degrees, so we're pi over 6 short of 12 pi over 6, 11 pi over 6. And these are the signs of the second derivative in each of these intervals: concave down, concave up, concave down. You can pick test numbers in each of these intervals, plug them into the second derivative, see if you get a negative or a positive number. I'll leave that to you. Here's what it looks like. Here's the graph of the original function in red. There is a relative maximum here and a relative minimum here. Notice that's where the first derivative is equal to 0. This green dashed line is the graph of the first derivative. The blue dashed line is the second derivative, which is this guy right here, or those two. And that equals 0 here at 7 pi over 6 and 11 pi over 6. And so these are the points of inflection: 7 pi over 6, concave downward. All of a sudden at this point, the curve becomes concave upward. And then at this point, it turns into concave downward again. Hard to see, but that's what's happening. Okay, and again, concave downward means the tangent lines are above the graph, and concave upward means the tangent lines are below the curve. Okay, there you go. Hope that helped. If you have any questions, post a comment.